All right, folks, good morning. Welcome to our webinar on confined space. People will still be coming in as we're moving forward, but today we have a guest speaker, Chris Irwin from MSA, and he's going to help us with all the different types of equipment and how all that pulls together with confined space entry. And as we move through the presentation, if you have any questions, be sure to put it in the chat. And at the end of the session, we'll try to cover as many of the questions as we can. That way, it's kind of everything flows. But with that said, let's go ahead and let's jump right into the presentation. So again, today we're going to be talking about confined space. But first, let's talk a little bit about our guest speaker, myself, and of course, Arbill. Arbill's been around now over 75 years, and we're woman-owned. Julie Copeland is our CEO. We cover both industrial and government sides of the business. And of course, we deliver a lot of different things, whether that's safety products with PPE, whether that's EHS services side, where we work with folks on written programs and training and all of that sort of things. But our main goal is to keep people safe every day. A little bit of background about myself. I've got a little over 28 years in EHS. Most of my background is in the poultry world. I hold a bachelor's degree and also have a general industry certification from the University of Alabama. Chris, I'm going to turn it over to you just for a few minutes and let you talk a little bit about yourself.
Thanks, Chuck. As Chuck mentioned, I work for MSA. I have a background as well in health and safety management. I have worked for MSA for, it'll be 10 years in January. And kind of my areas of specialty are fall protection and confined space. But I'm also an OSHA 10 and 30-hour trainer. And as I mentioned, that's kind of what my background is. But on the topic that we're here to talk about today, confined space, I probably dedicate at least a third to half of my time teaching classes, doing surveys related to this, working with our different customers and in a variety of different areas related to the topic.
Yeah, there you go. Well, I'll tell you what, let's jump right in. We'll go through the basics, and then we'll hand it over to Chris to talk about all the different pieces of equipment, and we'll jump right into it. So the basics. So just to kind of cover, fatalities and things of that nature, and just some basic statistics. From 2011 to 2018, over 1,030 workers died from incidents working in confined space. Most of these occurred from trench collapses, falls from heights, inhalation, hazardous substances, oxygen deprivation, routine maintenance, cleaning, and inspection activities. So what is a confined space, and how do we define it, and how does OSHA define it? Of course, you've got both a confined space and then what we call permit required confined space. So a confined space, and again, it has to meet all of these requirements, has to be large enough that the employee actually can enter and perform work. Number two, it's not designated for continuous occupancy. And number three, it has limited means of restricted means of exit and entry. So if we took a room or an office, it's large enough for us to get into, but it is designated for us to be in there. It may have limited means of exit and entry, but it has to meet all of these three requirements for it to actually be a confined space. So permit required confined space, there's certain conditions, things that we have to have in there to define it as a permit required confined space, and it only has to meet one or more of these. So it could contain potential or have the potential to contain hazardous atmosphere, the potential for engulfment, entrapment, and then other recognized serious and health hazards. And I call that the OSHA gotcha. Any other recognized serious or health or safety hazards. So kind of keep that in mind. So confined spaces come in many different forms: tanks, vaults, silos, pits, sewers, attics, crawl spaces. All of these things can be defined as confined spaces. But what are just the general requirements itself? So the regulations require employers to identify, inspect, and develop written programs and complete training for confined spaces. So if your facility has confined spaces, hopefully your employer has taken the steps to develop a written course, a written program around it, define where all the confined spaces are, and also do training in regards to that, especially if folks are going into those confined spaces. They have to evaluate that workplace and put together procedures as well for entering. So if they're going to be entering, they have to have those procedures in place, and signs and postings also to inform employees of those spaces. So the signs basically come in two different forms. You have just a standard confined space sign, and then you also have the permit required confined space sign. So you can see there on the screen, you can have two different versions of that. And again, they can be posted at the place of entry is mostly where you find those, but it can be placed in and around that entry point. All right, so permit required spaces require a lot of different things when it comes to OSHA and what they require the employees to have, as far as training, as far as, what written programs. The first thing is you've got to have people that are trained, and we break that out into three different areas, and OSHA breaks that out into entrance, attendants, and supervisors. You have to have a permit, and that permit has to be issued and completed in its entirety. And it's usually completed not only at the beginning of the entry process, but also throughout the process as you might be monitoring the atmosphere. Again, attendants have to be on the outside at all times. Rescue teams needs to be on site, or maybe you have someone on standby. They have to have a means of extraction of getting people out of those confined spaces, and then of course continuous ventilation. The written program itself has to be developed by the employer. You have to make it available to the employees so that they understand all the things that are put into that. And again, that is part of your training. And then, of course, all the details around hazards in those confined spaces. So not only is the confined space a hazard, but all the requirements around that. So what is training involved? So with that said, you got confined spaces. They have the attendants, the entrants, your supervisors, everybody has to understand what their role is and how that role plays out during the confined space entry. You also need to inform folks that might be affected by confined spaces to make sure they understand what the signs are about and not to go in unless they are certified. Permit. There's a lot of different permits out there. Everybody kind of has their own version of it. The one that you see here is kind of based out of what's in the standard itself. But again, it lists out all the things that need to be done prior to entry, as well as things that need to be accomplished throughout the entry process. So what are the positions and what are the duties and what are those responsibilities? So again, we talked about an authorized entrant, we talked about the attendant, we talked about the entry supervisor as well as the rescue team. So what all is involved in each one of those? So an authorized entrant, basically they have to be trained and certified and authorized by the employer to actually go into that space. So they're going to know the hazards, they're going to know the procedures, they're generally going to be doing some sort of maintenance or cleaning. So the job role could be different based on what the need is there. The attendant, the individual stationed outside. So this person is the key. They have to monitor everything, make sure everything's going right. If they see something that's wrong, they need to notify everybody, get everybody out. Or it could be a single entrant as well. But making sure that they're probably the biggest key, in my opinion, to everything is they have to watch everything, know everything, make sure they're following all the procedures and making sure everything is done properly. The entry supervisor, of course, usually this is a foreman or chief, a crew chief of some sort, and they basically are going to make the determination prior to entry whether the conditions are met to where you can actually enter the confined space itself. And again, they will be the one authorizing the permit and everything moving forward. And then also, lastly, terminating the entry. All right, so rescue team, again, these are individuals that are made up that understand how to get folks out. So whether this is a horizontal entry, whether that's a vertical entry, they know what it takes to get the folks out. You could also utilize off-site rescue if needed. But the main thing is that you have a way to get folks out of that required permit required confined space. So what kind of equipment is needed? So it comes many different based on the type of hazards, based on the type of confined space, whether it's a vertical entry, a horizontal entry, many different things. We could have harnesses, ropes, tripods, winches, ventilation fans, monitoring equipment, rescue equipment, communication equipment. All these things are included. There's also what we call precautionary equipment, kind of guarding off where you're going in and where you're doing entry. We want to make sure that that area is protected. Nobody is in or out or around that doesn't need to be there. And then lastly, the retrieval equipment. Again, full body harnesses, lifelines, mechanical winches, tripods, all the list goes on. And of course, I'm not going to steal Chris's thunder on this. So Chris, I'm going to go ahead and I'm going to let you kind of take over from here.
All right, I appreciate that, Chuck. So I'm going to kind of go through and, as Chuck mentioned, talk about some of the different equipment that is used in conjunction with controlling the hazards that we find in confined space. Typically, when I do a class, we start by talking about what are the various hazards. Why is this a topic of interest to us? Why is this something we should be concerned about? And then once we understand the concern or the risks, then we can talk about what can we do to protect ourselves or control or eliminate those hazards. And one of the major tools that we use for control is your gas detector. And we've got a picture of two MSA detectors on this screen that I'll talk a little bit about, and I actually might mention a third as we get a little bit further here. But the one that's on the left is what's called the Altair 5X. It is a pump-based device. If you were to look at the back side, there's an inlet, and for any of you that maybe have used these, when it's turned on, you'll hear a pump kind of whirring in the background. And on the right is what I would refer to as a diffusion-based instrument. So just to very quickly kind of run through the difference between these two, and then I'll get into some other important points. So with the 5X, I typically say it has its areas where it has its strong suits. For example, this can have a line attached to that pump on the back side. It's basically just a little quick connect that you clip in. And usually where you would first use this would be prior to entry, doing your evaluation check of the space before anybody ever goes in. The number one killer in confined space is bad atmosphere. And this is a fantastic way to, really the only way to know what the atmosphere looks like before ever sending somebody in. And you can, I believe with the 5X, you can do up to approximately 50 feet of line. And it usually comes in 10-foot increments. But you basically can lower the line in from outside the confined space. And again, as I said, see what the conditions are before ever exposing anybody. Besides the pre-entry evaluation testing, the other thing this is commonly used for, and by the way, both of these detectors look like they're the same size. The 5X is a little bit bigger than the 4XR, the one to the right. And so usually I leave this one outside the space the entire time. Once the entry begins, a common question I like to ask my students is there any required testing? Let's say we've done the initial checks and the numbers look good. So we're at normal oxygen and we don't see any other hazardous contaminants. but are we required to do any additional testing at that point? And the answer is what OSHA says is we need to do it periodically, which is a very gray answer. I don't find that anybody technically ever takes the gas detector away when the confined space entry is ongoing. So usually, or pretty much always, what I see is ongoing or continuous testing. So the 5X would stay in the hands of the attendant, and they could basically keep an eye on that screen with again, the line going down into the space the entire time the entry is ongoing. The detector on the right, the 4XR, also has its strong suits. As I mentioned, it's a little bit smaller. To start with, it's diffusion based, meaning there is no pump built into it. You would not hear that whirring noise or anything of that nature. But the air that comes into contact with those three white areas near the top, those are actually water filters. Basically, the air that comes into contact there is getting tested in the exact same way using the exact same sensors that are in the 5X. But this is a wearable device. So on the back side, there's a clip, and you would typically clip it on your full body harness. We'll take a look at a harness for confined space entry a little bit down the line here. You would typically clip it on somewhere around chest level. I have found if you get it right up below your head and you look down and breathe on it, you'll actually cause the O2 alarm to go off. So I usually go right around the chest strap on the harness. You don't want to get too low. You do want to kind of get it near the breathing zone. Now I say this is a wearable device. So this one here, you would typically take in the space with you wherever it is that you might go. So imagine the 5X line is dropped right in at the entry portal, but you're walking horizontally away. This you can take with you as the entrant and see what the conditions are exactly where you are. That's not to say that you can't get a powered probe to attach to do testing from the outside. You can. It's just what I commonly find is a lot of times sites maybe originally got that piece and then have misplaced it, and now all they have is a detector. And one brief comment I'll make is without the proper technology, it isn't okay to just attach this to a string and lower it into the space to do your testing from the outside. I really need to caution you, whichever device you're using, you want to make sure you're doing it the way the manufacturer specifies, just to know that you're not going to run into any kind of issues and you're doing it the way they want you to. Technically, both of these devices could be used either way, but as I mentioned, I think they each have a strong suit. You don't need to have both. You could have one or the other. But if you've got the capability of having a 5X on the outside and 4XRs on the workers in the space, even better. So just a little info on what the gas detectors can do and just some of the sensors that are in them. The first thing I really need to say about gas detection is the detector is only looking for what it actually has sensors for. In other words, there is something out there that's called a mass spectrometer, where it's a giant machine as big as a room, where you could put any kind of gas in there and it could tell you exactly what that gas is and in what quantities. Your portable gas instrument is not that. You need to have an idea of what is potentially in the space or what might be lacking in the space in the case of oxygen, so that you've got the proper sensors to search for those things. Typically, you'll hear these referred to as 4-gas monitors, meaning they're looking specifically for what would be the most common atmospheric conditions. So, for example, you see these below where it says factory set points. This is where the alarms will go off on these things. One of the more common, or the most common thing we test for would be oxygen. It can technically get too high, but I would say the more common issue is oxygen concentration getting too low. So you can see here it talks about the alarm will go off if percent oxygen in the atmosphere is less than 19.5. Per the MSA detector, it should be reading 20.8. That is the percent of oxygen that should be in the atmosphere. There's also a sensor for combustibility of the atmosphere. And I'll talk a little bit more on this in a future slide, but combustibility, CO is carbon monoxide, and H2S is hydrogen sulfide. Those would be the big four most common things that a gas detector is set to check for. And I would say 90 to 95% of the time, those will have you covered. But again, you need to know your space and know whether or not something else might be there. If you don't know what potentially is in a space, then the only way that you could properly really test that would be getting what's called an industrial hygienist, who could take a sample of the space and then, again, through laboratory testing, tell you what they found. But again, if you are going into a sewer or a space where you know what's already contained in there, then you've got enough info to know whether or not you've got a detector that will work. As mentioned, these are going to directly measure, display, and record specific substances. They have low and high alarms that will go off. I honestly tell people, forget about the high alarm. As soon as any alarm goes off, the low alarm, you need to either, if you're not in the space yet, not be going in. If you are in there, getting out of that space. They'll typically let you know with an audible, an LED, and or a vibrating signal. So they'll let you know various ways that you've got an issue. And also on our detectors, for example, with the LED, it will change different colors depending on what it's trying to indicate to you. So if it's red, that would definitely indicate a bad condition. But it also could indicate that the detector is not properly calibrated, which we'll talk about what that means. Or it could mean that a sensor is going bad. So these things will give you a lot of information. You just need to know how to interpret that. And at the bottom here, it mentions exotic sensors. So we do run into some cases where there might be other things that need to be tested for. The exotic sensors, such as ammonia, which is common in refrigeration, chlorine for, I'm thinking like sewage treatment, something of that nature. Sulfur dioxide is common in like chemical type facilities or processing of different types of oil derivatives, oil and gas. So we do sometimes need other sensors. Those things can be bought or in some cases even purchased and put into the detector after the fact, if you know that you need something beyond what the normal detector is set up to detect for. So one of the things I like to do with my students is put up on the screen kind of an example of what or put up on the board, the whiteboard, or in the presentation, what a gas detector screen is actually telling you. And if you were my students in person, I would probably quiz you on some different things. But I'll kind of just give you some of these answers here. As I mentioned, the detector is going to tell us what the quantity of O2 is in the air. I often will ask, for example, if your screen says 19.6, will you go in the space? And that's maybe a little bit of a challenging question because the alarms are not going off. Remember, 19.5 was the number where that happens, but it's not 20.8, which is what it should be. So I'll get some people that say, well, if the alarms aren't going off, I'm okay with that. Others will say, well, that's a lot different than what it should be, so I'm concerned about that. The thing I stress is you as a company need to define acceptable entry conditions for your workers. That is an OSHA requirement. So you're really on your permits, you should be spelling out what those conditions should look like so that workers know when they see something on the screen, is 19.6 okay, or is it too low? In my book, in a perfect world, I want it to read 20.8. So I would want the workers stopping and trying to remedy that situation. And I could say the same thing really about all the different things on the screen here. Combustible, you can see where the alarms will go off. You can see what normal should be, carbon monoxide, H2S. And all these things, all these numbers measure something different. So O2 is percent of oxygen in the atmosphere. The combustible sensor tells us how close are we to the lower explosive limit for the whatever substance is in the air. And then the other two are giving us measurements in parts per million. So each one of these things is measuring different specific things. This just gives you another view of what it was that I said previously. So the Altair 5X, you can see there is a pump. There are filters that are built in. So in the back side, we can't see either of these filters, but in the back side, right where that plugs in, there is a hydrophobic filter. And then in the wand, the plastic black piece at the end of the tubing, there's also a hydrophobic filter in there. That said, you want to be careful not to let the line dip in water because that filter will, from my experience, take a long time, and I'm talking weeks to probably dry out. So it's good to have some extra filters on hand that you can pull that wet one out of there and put a new one in. But even better, you don't want to allow that line to dip into the water because we are trying to protect the sensitive electronics inside the instrument. As I mentioned, this is great for pre-entry testing before we ever send anybody in the first place. And it's great to stay in the hands of the attendant for ongoing continuous testing as the confined space entry is ongoing. Common question I get is how long can it run? Both of these can run as much as, I think, nominal times like 18 hours. Once you start adding features, though, it might drop a little bit to, 15 or 14 hours. And some of that also depends on age and things like that of the batteries, but they do last a pretty long time. Here's the setup for the 4XR. Once again, it's a wearable instrument. Here you're actually seeing where it has a snap-on cap that allows you to attach the sampling probe. So it can do what the 5X did or does. But for me, the strong suit for this particular device is unclip that cap, put the 4XR on your harness, and wear it into the space. Something that is really important is this concept of calibration. Basically, I'm sure a lot of you that are here probably generally know what calibration is, but we need to make sure that the readings that the detector is giving us are correct. And what we will do, and we'll have a picture of this in a coming slide, but we'll take a bottle of what I call bad gas, where we have a known concentration of low oxygen, we have flammable substance, we have carbon monoxide, H2S, all those things. And we will put the detector in test mode, calibration mode. And basically, there's a couple ways of doing this. There's what we call manual, where you would have to physically push buttons on the detector and lead it through the test. And from my own experience, you need to know how that works. I do see people that are pressing buttons at the wrong times or not pressing buttons and things like that, and the test won't work. So it does require training to do it the right way. It's not extremely complicated, but it requires training. But basically, the two things calibration will do is it'll, number one, check to see, are the sensors reading within a defined range? So we know in the bottle of gas, for example, that we have oxygen at 15%. If it's anywhere between 14 and 16, it'll pass the test. That said, we don't want you getting an incorrect reading. So if it's within an allowable range, the second thing that'll happen is the detector will automatically adjust readout so it's correct. So it'll auto adjust. Now, if it's outside the range that's allowable, it'll fail the test. It'll tell you that sensor is bad. That doesn't mean you have to get a new detector. That just means you need a new sensor, like we can see at the top of the screen. It will tell you that right on the screen, at the end of the test, and it really won't let you forget that. It'll show you a heart symbol in some cases on the screen, letting you know, hey, this needs to be replaced. When it comes to calibration, we don't want you to go any more than 6 months without doing this. That's even if you're not using it. And then best practice to keep the sensors properly exercised is do this monthly. And all I'll say is I'm a runner, and the example I give is it would not be a great idea for me to go 12 months and then try to run a marathon the next day without training. Same thing is true here. If I don't expose these sensors to gas ever, and then I just expect to take this thing out and use it, it will not work as well. So that's really what calibration does, is helps those sensors know what to look for, and it also tells us that everything's working properly. Here's the example of calibration gas. It'll tell you on the label what is in that bottle. That is specific to the test on the detector. It is important that when you put it into test mode, or when the detector's starting up, it'll tell you specifically what quantities of gas it's looking for. If the numbers that read on the screen are different than what reads on the bottle, once again, it will mess up the test. So this is something you need to make sure you've got proper gas that matches up with what the detector actually thinks it's looking for really that entire process to work. There is an additional test that we get into called bump testing. This is a daily check. Now, when I say daily, this would be a pre-use thing. So if you're not using a detector on a given day, I would not tell you that you need to go and do this. But prior to use, similar to if you're using a harness for doing entry or doing fall protection, you would need to inspect it. This is just a very, very quick check that makes sure that that same gas in that bottle that we just looked at is able to get to the sensors and trigger alarms. So it's not doing everything that the calibration did, but it is, and you would see if I were to demonstrate this manually, the bump test maybe lasts, I don't know, 15 seconds, whereas the calibration can last 1.5 to 2 minutes. So you can definitely tell the difference. But this is definitely important too. So in my world, we would do bump testing each and every time we use the detector at the beginning of the day. And then we would be doing a calibration monthly, because that's, what really in my world would be my recommendation. One thing you might see, this is actually what's called a cylinder holder and test stand, or a docking station, where you can actually screw the bottle of gas in, and it can do auto testing for you. In fact, it can do a lot of different things, but I simplify kind of what this does to, once it's powered on and everything looks green on the station, you can take your this is the kind of the same small detector that's diffusion based, but you can also get this for the larger pump based device. You can plug the thing in, and it will automatically do your calibrations when needed, and automatically do your bump instead. So there are settings in here where once you plug the running detector into the holder on the right, it will, without you pressing any buttons, it'll do all the testing for you. And this is only showing one detector, but you can get multiple test stands. I think it's up to 10. So you could run a whole bunch of tests at the same time on a bunch of different detectors. The more detectors you get, the more auto stations like this tend to make sense. So I do run into a lot of students that have something like this at their facilities. So I talk a lot about the gas detection, but there's other components. There's other things that we use to control the situation the best as possible. So this next section is just a quick overview of some of the entry/rescue devices that we have. So Chuck, go ahead there. So one of the things we need before we even worry about the entry device is the harness. There's really two types of confined space harness that I see. You're looking at the one that we use in our training. This is MSA's V-Fit harness. But what's specific about it is it has a back dorsal D-ring that we can't see behind the pad. And then on the front, there's also a sternal D-ring. And this is important, and you'll see this here momentarily once we look at some of the other, the actual entry devices. But you'll typically have two lines. You'll have one that's for fall arrest that will go to your back D-ring. That's always where we attach for fall arrest. And then in some cases, not all, there will be a winch line that is going to lower you into a space, for example, that doesn't have a ladder that will attach to your front. We are not allowed to attach two hooks to the same D-ring. Therefore, if I had a harness just with a back D-ring, but I needed to be lowered into the space, I need fall protection and I need lowering. Both those hooks cannot go into the same back D-ring. So you might have a harness as a front and back D-ring, or the other possibility is you might have a back D-ring with shoulder rings. I don't like those as much. That's why I didn't put one in here, but the shoulder D-rings would be used instead of the front sternal D-ring, and you would have to have what's called a spreader bar that hooks into those D-rings coming off the winch to lower you into the space. So here is a very traditional tripod that has on the right-hand side what we call our MSA rescuer. It's a fall arrest device that has a built-in winch in case we need to pull somebody out in the case of an emergency. So I call it a 2-in-1. It's got fall arrest capabilities and winching capabilities. The device on the left is the MSA winch. That is the device that's purely a working winch. There's no fall arrest capabilities. If in a scenario where you had a ladder to climb down into the space, you would use the 2-in-1 on the right. And you would usually use it in winch mode, in fall arrest mode. And that would be attached to your back. You would not have the device on the left. In a scenario where there was no ladder to climb, you would use the fall arrest on your back D-ring and the winch on your front. It is not acceptable to use only the 2-in-1 and to use it in winch mode for regular entry, lowering somebody in. That winch that's on there is simply for emergencies. If you have a scenario where somebody goes down inside the space, or you have a fall where they become unconscious when they're climbing in or getting lowered in, you can put that into winch mode. There's a handle on the far side, and there's a knob that you turn to put it into winch mode to simply pull that person out. So there's a lot more I could say about tripods and these devices, honestly, but that's kind of the lowdown on what you're looking at right here. This is the same exact concept, but it's what I'd refer to as a davit system with a barricade. So the 2-in-1, the Workman Rescuer is on the top side, and the winch is on the inside. So you're doing everything the tripod would do, except for here. I think for me, there's added benefits. You've got a barricade, whereas the tripod did not give that to you. And you've also got a little bit easier setup. If I were doing a demo on how this thing came together, you would see I have an easier time setting this thing up. But otherwise, it does everything a tripod does. Fall arrest. It does lowering somebody into a space. And in the case of emergency, it can pull that person out. Same thing here. These are just some different types of davits where now you don't have the barricade. Here you have a fixed base plate and a different type of davit that slides into that plate. So if you've got spaces around your site where, or let's say you've got 30 or 40 spaces, you could buy 30 or 40 base plates, permanently affix them, and then you could buy the rest of the system from the base plate up, from the gray part up, and you could just transport that around. There are different setups depending on how far you need to reach over that space horizontally. Same thing, just some other ones. The one on the left would squeeze like a wall. The one on the right is a collar that goes into manholes. Think of like a train car. Could be a manhole going into a sewer on the street, any of those kind of things.
All right. So, Chris, I think the next thing is the video to kind of, you might want to introduce that, kind of what's going on there.
Yeah, so this next video, we'll play with the little bit of time we have left here. This is me demonstrating several of these things that I've discussed on our training tower at the MSA facility in Pittsburgh, PA. So you see I've got my confined space harness on. I've actually got a follow wrestle lanyard on as well, which will not be part of kind of what we're doing here. I've got the 5X detector, and then I've got the davit barricade system behind me. So this is pre-entry testing of the space as I was describing earlier, and I'll talk you through a few more points as we go through the video.
All right, let's get it going.
Hi, my name is Chris Irwin, and I'm here with MSA training to talk about confined space atmospheric testing. One of the two gas detectors that I'm going to use today is what's called MSA's Altair 5X. This particular detector that I have tests for oxygen, combustible atmosphere, carbon monoxide, and hydrogen sulfide. The first thing that I need to say before anything else is you need to make sure that you've got a gas detector with the correct sensors to look for the actual or potential hazards that you could run into inside the space. For example, if there is a toxic gas that requires a special sensor, but I don't have it, my gas detector is not going to tell me anything necessarily. So it is very important that I have some kind of an idea of what I potentially could find in that space when I start my test. The other thing that we are assuming as I start to do this test is that my gas detector is properly calibrated and, for today, bump tested. So let me just quickly define those. Calibration is where we take a known quantity of the target gas, so low oxygen, flammable atmosphere, hydrogen sulfide, carbon monoxide in this case, and when the gas detector is in test mode, I hook a bottle of air with those gases up to the detector, and it does two things. Number one, it's going to check to see whether or not it's reading correctly. My detector is typically going to know what is in that bottle, and it knows what it should be reading. So it's able to verify whether or not the reading during the test is correct as to what's in the bottle. So it's going to check to make sure the sensors are still functioning. And then something that can occur over time is what's called sensor shift. That's where the sensor starts to go bad, but it still potentially is useful. As long as the reading is within a defined range that's considered to be okay, the sensor can stay in the gas detector, and basically the gas detector will change the readout on the screen so that it's still correct, even though that sensor is maybe starting to read off just a little bit. Now, if during calibration the sensor is way too far gone and the reading is way too far off, it will not even pass calibration. So calibration checks to see if we're within a proper range, and if that readout is shifting a little bit, but it's still acceptable, it'll reset the readout so it's exactly as it should look. We typically say that calibration should take place no more than once every 6 months. I typically recommend doing it at least monthly. The other thing I mentioned is what's called a bump check. The bump check is something that we do basically every single time prior to using the gas detector. Now that's assuming I haven't just done a calibration today. But the bump check is a very quick check to make sure the sensors are still within the proper range. It's not going to reset readouts. You'll notice when you do it, it is a quicker test, but it's just like your, for example, daily inspection of your fall gear that you'll also be using for the entry. So with those things in mind, we are going to talk about a couple types of testing. So the first thing I'd like to kind of go through is the gas detector typically will have some other elements, and one of those main ones is going to be this probe and some line that we're going to attach. Now I'll set that to the side one moment to talk about my first step in testing. what I typically tell my students is before I do anything else, I'm going to get down here and put the gas detector right beside maybe a crack in the manhole or a small opening if there is one, to try to get a measurement of what that atmosphere is like at that entry portal before I open the hatch. I tell them if I find any kind of atmospheric reading at this point, things will probably be a lot more significant when we open the hatch. So it's not a bad idea to do a quick check. Now, I always ask my students when I put the gas detector down here, how long do I need to wait to get a 100% or pretty close correct readout? And once again, that is going to depend on the sensors. If you read the manual that comes with the gas detector, typically we tell you that the sensors will have what's called a T90 time. The T90 time is how long will it take each one of those sensors to give you a 90% accurate readout, which is what we typically consider to be acceptable. In general, I typically tell people, at least for the gases that I'm checking for today, we're talking about 10 to 15 seconds. But I know for other types of sensors, we could be talking more than a minute. So again, that's something to always check the manual to see what the T90 times are for the different sensors. Right now, my gas detector is reading 0 for everything except for the oxygen, which is at 20.8, which is the standard atmospheric air reading that MSA has on the gas detector. So at this point, I'm going to go ahead and start getting ready to test the atmosphere inside. The first thing I'd like to quickly show is here is the probe that's going to go on the end of the line for the 5X. Right here is a filter. If I accidentally do drop the end of this in water or a liquid, it'll get plugged up in here. So you don't want to drop it in any kind of a liquid, but there is kind of a stopgap if we accidentally do that. In fact, on the back side of the gas detector, right where the inlets, there's a pump built into this, right where this inlet's at, there's another filter right there to stop any water coming through. Line typically comes in sections of about 10 feet. And I believe you can get up to about 100 feet. I'm not sure what the ultimate limit is, but somewhere in that range, depending on how much line you need. I'm just using 10 feet today to do this test because my space will say is no deeper than that. This is going to attach to the back of my gas detector. Now with the MSA detectors, it's very common that when I first put that on there, just checking my additional alarms there to see if there's any kind of an issue. But as I was saying, typically when I put that probe on there, it is very normal for the alarm to go off briefly, mainly because it's noticing a difference between how hard it was to pull air prior to the line being on there and how hard it was with the line being off. At this point, I am now ready to go over and start testing in the atmosphere. Now, you'll notice that in this case, I actually have my fall protection up. I always tell people I like to have this to do my atmospheric testing. I always tell people that I like to have my fall protection on to do atmospheric testing, mainly because if I do find something inside that space that could knock me out when I remove the cover, I've actually got something to prevent me from falling into the space.
All right, Chris, I'm going to stop it right there and let you fill in some other details.
Yeah, so yeah, there's always, this is a topic that I'm used to talking on for 2 days straight, so there's always more that I could say. Basically what I get into at that point is talking about where do we test, and the minimum is at least top, middle, and bottom due to stratified gas. I need to be careful that I don't have something that's lighter than air at the top of the space that we don't test because we just drop the probe to the bottom. And then the other thing is talking about how long do I leave the line there once I've added the tubing. So it's the T90 time, usually 10 to 15 seconds for the detector. And then it's 1 second per foot of tubing that I attach. So I think in that example, I attached 20 feet of tubing. So that's going to be 20 plus 15. So again, just talking through the technical details of how to use that detector and make sure that we're getting an accurate readout. And then all that info would get put onto the permit as a record of us having done that, showing kind of, in case anybody asked what that process actually looked like at the time of entry. So like I said, there's definitely more that what I would typically get into, but that you at least see what that looked like at the stage where I was about ready to pull that cover, drop that line down in there. If everything looked good, then the entrant would probably step in, and once everybody signed the permit, the entry could begin, assuming that all the other controls like lockout, tagout, and things like that are in place. But with that, I want to make sure we leave a little bit of time for any questions. So I'll let Chuck kind of be the moderator here, and we'll go ahead and answer whatever we can.
Right. I'm going to stop sharing here just for a minute. And so first question it looks like is, will the GX2 automated test system be sufficient for automatic calibration?
Yes, absolutely. So the GX2, you might remember the picture that I said where we had that test station that had the green lights on it, where I said you could just plug in the detector and it would automatically do your testing. The GX2 is a type of test stand that's been out maybe 10 years, something like that. And it would be the test station for the Altair 5X that I showed and for the 4XR. There is a new station that's come out or a new type of system called the IO4. I don't probably have a lot of time, and unless somebody had a question in this vein, but it's a cellular-based detector that basically is kind of like a cell phone and a detector at once. But it can send values of what you're reading in real time to the cloud, so that, say, Chuck is the Confined Space program manager. He could look and see from wherever he's located in the U.S., he could see entry going on in Houston in real time, what the numbers look like. So there is a different test stand for the IO4, but it basically does the same things. But absolutely, the GX2 is designed for the 5X and the 4XR that we looked at.
Yeah. All right. So the next question is there a good way to non-entry rescue an entrant, and are there any options to test for combustible dust? So we'll just take that first one. I'll let you kind of run with that one, Chris.
Yeah. So there's two types of rescue. There is non-entry, which is where you don't have to send anybody in the space to do the rescue. And then there's entry, where you're actually sending rescuers into the space. The preferred is always non-entry. That's not to say you're not allowed to send rescuers in, but you should try to set your system up so that you can pull the person out without ever having to send anybody else into harm's way. The preferred way, or the only way that I'm really aware of, is you leave a person attached to the 2-in-1, to the MSA rescuer, when they're in the space. And if they do pass out, if something does happen where they can't get themselves out, that's where that rescue handle comes in. You can pop it into rescue mode and pull them out. That said, you need to know that they're not behind obstacles. They're not going to get tangled in something. They're not going to go so far the line won't reach. There are lots of factors, but assuming you're going straight down in and there aren't obstacles between them and the exit, leave them hooked up, and then you can pull them straight out on that rescue handle. That's the entire reason that's built in.
Okay, good deal. I think the next question is, there are options to test for combustible dust?
Not in this type of detector. From what I understand, that would be more of an industrial hygienist type thing, where they'd have to do a sample and take it back and tell you what your quantities were based on, based on what they sampled on that particular day.
Yeah, That's exactly what I was going to say. An industrial hygienist can handle that. And at Arbill, we do have industrial hygienists, so feel free to give us a call. The test gas bottles have expiration dates. How important is that date, and what is the correct way to dispose of those bottles?
Yeah, it is important. From what I understand, the one gas that will go bad is hydrogen sulfide. So it will break down on a molecular level and not work for you after a certain period of time, usually 2 years. So it'll tell you on the bottle when it does go bad. You need to not use it after that date. As for disposing it, there is a tool that you can buy that will devalve it. You would do it outside. So you would just screw it in. It would take the valve stem out of there, and you could drain whatever gas is left, and then you can simply recycle the bottle. So you can do that. I don't know with Arbill, maybe you guys have like a process where they could turn it into you guys, but a relatively simple process.
And the last question we have is, do meters have a preferred life expectancy as far as timelines? Is there, how long is a meter good for, basically?
Honestly, that probably depends on lots of things like conditions of use, what kind of things you're putting it up against. But, if it's an industrial setting where it's relatively light use, honestly, you could probably get 20, 25 years out of these things. The part that will go bad is the sensor. Those things will show what's called sensor shift over time. But the good news is you can buy replacement sensors. And I think a lot of those 4 sensors that I talked about have warranties on them of like 3 to 4 years. So if one goes bad prior to the warranty period running out, then you can get a brand new sensor at no cost. But other things can go bad in the sensors, and with the detectors, if they do, you can get repairs. Just like a car, you can send it to the shop. They can fix whatever it is that's wrong with it. Within reason. If it's really poorly treated, then I can't say you can save it. But if you have a good program, at least with the MSA detectors, I've found that they last a really long time. I honestly haven't seen too many that even if they're 20 years old that I can't use. The only thing I'm needing to replace is sensors.
Sensors. Yeah, no, I completely agree. I think that brings us basically down to the end of all the questions. If there's anything else, folks, we're right at our timeline. So love to address anything, any issues, any concerns through Arbill. There's my email there. If you'd like to email me with any questions, any feedback, you can leave us. You can use the code there and send that off for us, and we would sure appreciate it. As we bring more webinars to you, we can make improvements. And again, we appreciate everyone's time. And Chris, we really appreciate you being a part of this today and sharing your insights. So thanks everyone for your time. And again, hopefully we'll see you on another one. Thank you.